Greeting to all the honorable judges. My name is not Afifah Abdullah and my partner is Nivaashini Sandran. We will be presenting our research study entitled Pt-TNT for conversion of carbon dioxide to methane.
Why need to convert carbon dioxide? Well, energy demand mainly depends on fossil fuel, coal, petroleum and natural gas. Almost 80% of global energy consumptions come from natural resources, although these fuels are reduced due to their non-renewable sources. In addition, hazardous gases are released from fossil fuel that have been burned to produce energy. The consumption of fossil fuel energy major determine the impact on nature, which deem a critical cause of global climate change. Carbon dioxide is one of the prominent greenhouse gases among other greenhouse gases that absorb infrared light and re-emit it in the atmosphere, where it is trapped, resulting in global warming, which is affect human health and quality of life. As a consequence, the carbon dioxide emissions have been identified account for the 75% of maximum global greenhouse gases emissions. Due to the exhausted condition of oil and gas production, human beings are facing a horrible loss of resources. Global energy is growing even faster than fossil fuel capacity. Global warming caused by the intense extrication of carbon dioxide concentration in the atmosphere occupied with the burning of fossil fuel, as entails a great concentration that need to be addressed environmental challenges related to climate change. In order to produce renewable energy, scientists are seen to be very concerned in carbon dioxide, which is one of the most common carbon-containing sources in nature. Scientists are confident that converting carbon dioxide waste emission into alternative energy source and then at the same time significantly minimizing atmospheric carbon dioxide level by using sustainable renewable energy to accelerate photocatalytic reactions, which could provide a feasible option. This invention focuses on novel nanocomposite photocatalyst synthesis by implementing chemical reduction method. This photocatalyst utilizes the visible light for the production of hydrocarbon fuel through the photocatalyst carbon dioxide conversion. Therefore, the hydrocarbon fuel CH4 can be used as domestic fuel and power generation purpose for the fulfillment of future energy demand, as well as reduce the increased amount of carbon dioxide from the atmosphere. Limitation of nanoparticles. Quick and limited light absorption, slow reaction, poor selectivity and other things can reduce the yield of productivity, and a high recombination rate of photogenerated electron can be formed during the photocatalytic activity. Objectives. First, to synthesize the TNT and platinum TNT for gas conversion. Second, to characterize the physical, optical and plasmonic properties for the synthesized photocatalyst. And the last one is to evaluate the photocatalytic efficiency between platinum TNT and TNT.
In this photocatalysis process, titanium dioxide is the most widely used photocatalyst due to its availability and its high photocatalytic activity. In this research, a surface modification has been carried out towards titanium dioxide to form titanium nanotube TNT for the purpose of to provide large surface area as well as to enhance the photocatalytic activity. However, due to its limited absorption of visible light and higher recombination between electron and hole has limits its efficacy as a visible light photocatalyst. Hence, another modification which is doping platinum with the titanium nanotube has been carried out as it can improve harvesting of visible light. With this modification, the final product, which is Pt-TNT, will be an efficient photocatalyst compared to the existing product in the market, as it can enhance the photocatalytic activity of CO2 reduction. For product invention, as you can see in the schematic diagram below, a surface modification has been carried out towards titanium dioxide precursor through hydrothermal method to form titanium nanotube TNT. 3D structure of titanium dioxide powder will form lamellar sheet during hydrothermal treatment and promotes to the formation of high purity nanotube during acid washing process. The sample was then undergone chemical reduction process to distribute the platinum nanoparticle into the titanium nanotube. A short video will be presented to show the steps involved during the preparation of Pt-TNT photocatalyst. As you can see in the product section, the achieved photocatalyst product will be in powder form. Transmission electron microscopy (TEM) analysis has been conducted to analyze the morphological image of prepared photocatalyst. As a result, the synthesization process was considered success as the nanotube structure and platinum nanoparticle occupied the nanotube are noticeably represented.
Product functionality. The workflow of photocatalyst carbon dioxide reduction over as prepared catalyst has been conducted through gas-solid phase photoreactor and presented in picture below. From the graph on our right top, we can conclude that the methane production amount of the TNT is lower compared to other photocatalysts. The production amount gradually increasing for the prepared platinum TNT, which considered as a stable performing photocatalyst. The lower amount of methane produced for the TNT under visible light is considered as a UV light active catalyst. The little increased amount of the methane production for the TNT is because of its surface modification that improves the light absorption in the visible light region. The enhanced photocatalytic activity achieved for platinum TNT as a photocatalyst due to LSPR of platinum nanoparticles, which capture the photon energy efficiently from the visible light, and platinum provide rapid pathway to trap the photogenerated electron from TNTs, leading to enhanced separation of charge carriers. Thus, the total methane yield increase for platinum TNT through photocatalytic carbon dioxide conversion.
This whole slide shows that our synthesized photocatalyst, which is platinum-platinum nanotube Pt-TNT, has successfully modified into a more efficient photocatalyst for carbon dioxide conversion. UVV's absorption spectrum analysis proved that Pt-TNT photocatalyst has a wide absorption range in visible light spectrum, which is in the wavelength range of 400 to 700 nanometer. The bandgap energy of Pt-TNT also had reduced from 3.2 electron volt to 3.1 electron volt after conducting the modification process. This is due to the incorporation of platinum nanoparticle towards titanium nanotube. With these attributes, it is proven that our synthesized Pt-TNT will lead to a better photocatalysis process of CO2 reduction under visible light spectrum. Through this research, a novel nanocomposite photocatalyst has been successfully produced. This synthesized photocatalyst can act as a visible light active photocatalyst, and it is also easy to produce, lightweight, and stable under different temperature and pressure. During photocatalysis process, carbon dioxide will be converted into methane gas, and this methane gas can be commercially used as a fuel for oven, homes, and for vehicle. And last but not least, the product can also be applied for electricity generation.
According to an environmental friendly features, this invention also leads to fruitful implication of novel photocatalysts extend towards the gas phase photocatalyst conversion of carbon dioxide to light carbon. The light hydrocarbon CH4 methane can be used as alternative source of energy, a great enhancement performance of the reduction of greenhouse gases, and this work signifies both energies and environment. Next slides are about form and template of intellectual activity and industrial collaboration.
So next, these are the potential market for our synthesized photocatalysts, which are Nano Malaysia Berhad, Tenaga Nasional Berhad, and also Green Tech Malaysia. The market price for the synthesized TNT will be approximately around 6 ringgit per gram, which is quite similar with the available product in market. While for Pt-TNT, the estimated market price will be around 11 ringgit per gram. It is estimated to be double the price of TNT, as its preparation is the continuation of TNT preparation. Even though Pt-TNT will cost you higher than TNT, but it can provide you double efficiency during conversion of carbon dioxide and will simultaneously result in higher production yield of methane gas.
Market ability. From the pie chart, we can obtain the acceptance of product by community and cautionary template of market value.
And these are the awards and achievements.
These are samples of our brochure.
With that, we end the presentation today. Thank you for your kind attention.